I would like to talk about a little bit about the Metaverse, right? It's a very nice name. It's a marketing name, and then we can talk about 6G. It's also a nice marketing name. And let's see what kind of things we can talk about. So first, what we are doing at the university, we have several projects. One is our Excellence Cluster CETI, which stands for Center for Tactile Internet with Human in the Loop. And then you see the word Metaverse is quite funny and way better than the other one, right? So often I now say Metaverse, but what we really mean is a virtualized world where humans can interact with virtual objects, but also with real objects. So if you see what people currently doing in the Metaverse, they would like to bring this same old story from the web page to the Metaverse. So for example, saying stupid things instead of writing it, you're now walking around as an avatar and then you say stupid stuff. Or Amazon is trying to get the products not anymore listed. Maybe you have it in a three-dimensional way. So everything is really linear, right? But what else could we do there? And one of the things that we are currently trying to understand is how can we interact, for example, with a robot, right? You had already Wandelbots here. This is one of our startups. They try to teach a robot without code, right? You have a trace pen, you show him something, and after you show it many times, you get the intention, and then you can check it on the iPad, and then it will go. Why do I have, or why do I need the robot with me at the moment? So in COVID times, a lot of people ask, can I also do this in the virtual room? Why not in the Metaverse? If you want to interact with a robot or with any other cyber-physical system, there's certain things that you have to do. One of them is you need to bring the actual real stuff into the Metaverse that you can do by scanning. But when you interact with that, then in the Metaverse you will hear something and you will also see something, and therefore we have these Oculus Rift glasses or other glasses. But what is missing is the touch. Who of you knows something about touch, or who believes that touch is important for the Metaverse? Some of them. Why do you believe it's important? It's nicer? Yeah. In 2010, I had a startup. It's called Me. It was sex toys. Yeah. Way too early if you go to Silicon Valley with this idea, and they were all shocked. 2 years later, they called, you still have that? Right? So touch is not only for that, but it would be nice. But it's very important for learning. So I just want to give you an example. You know all these flight simulators, right? Microsoft Flight Simulator is the most used one for private issues. But then Lufthansa has its own flight simulators. They cost a lot of money, a lot of time, and to schedule this. Why don't they just give out the Microsoft Flight Simulator? It's very good. There are all the knobs. There's everything you can see. That's a real airplane. It looks very nice. Because the real learning is not only seeing and hearing something. You need to touch the knobs. You're not looking while you're doing something. When you do it in the virtual world without touch, you would always look what you're doing. Did I touch the button? You would check it. So you're missing one of the sense. And haptic is not everything. Smell is something, but I only have 20 minutes, so I don't go into that. So the thing is, we would like to create the Metaverse in order to interact with machines. So imagine the robot is staying in Japan, and you would like to teach him a certain task. And you're the only guy that can do it. So nowadays you can go to the airport, and you know how bloody it is to fly in these days, but only to go there it will take time. Why not bring the robot into the virtual world and then you interact with it? So we can teach it. Then the question is, what do we need for this? And we need communication. Communication is the number one thing to do this, and then people say, oh, this is why we need 6G. No, you can do this already now with 5G. Not with the crap they install currently in our networks, because this is not real 5G. Yeah, non-standalone networks is not 5G. This is only to make iPhone people happy to have the 5G logo in it. So what we really need is a 5G network that is fully softwareized, so in-network computing. And there are two things that you all heard about: mobile edge cloud, network slicing. And a mobile edge cloud is needed to bring down the latency in the communication. So latency is important. Why is latency important? if you interact in the digital room, you know the digital sickness you get dizziness when the video is a little bit lame. But even the touch, if you don't feel it in the correct way, you don't feel the right stuff. So we are talking with psychology people, and psychology people tell us video sensibility is 50 milliseconds, audio sensibility is 3 milliseconds, and haptic 1 millisecond. That does not mean that all of us are in this range. For example, if you play a music instrument, you need the 3 milliseconds. If you don't do that, maybe with 5 milliseconds, you're good to go. Then it depends also on age. Yeah? Sorry to say that, but if you are 50 like me, you have no chance to win FIFA 2020 against your students. The performance is more or less 3 dB better. Okay? Hey, my slides. Do I have a click? Oh, here's a clicker. Wow. And so you have to bring down the latency. And I think I have the slide for this. Forget about all of that. That's what I told you, right? Flight simulator, you remember? I would like to go. Coming to this in a minute. Can I go back? Yeah, I can go back. So first of all, why humans need can you click on the video? I think you have to start it. That is a glitch in the videos. Yes, Jessica. Here you see a human. That video is so old. Hartmut has seen it, I think, 20 times. The human tries to catch a ball, right? And the difficulty comes that there is a gadget, and we delay reality by LTE latency, 40 milliseconds. That tells you you will never be able to interact in the metaverse with 4G. But also not with 5G release 15 non-standalone. Not even with release 15 standalone. You need something like release 16, better is 17, right? So that is one of the things. The other thing that I would like to show you is this one. This is something where we did cars over the intersection. We are steering them with the mobile edge cloud. Everything is fine. And the number of cars you can get on this lane depends on the latency, right? Not on the mean value, on the worst value that you get. And this is, on the left, you see standalone against non-standalone measurements. Currently, they're not good enough. So, and in our world, some of you have seen outside, there are some people talking about campus networks, people talk about 3D networks. We have a wide area of networks with different architectures. And the question later is this 6G in the end, right? What is really important is the evolution of networks, right? So on the left, this is the good old telephone. When you went to grandma, you remember her phone with the dial, where you dial very nicely. This is the network, and then in the middle, this is the internet, where you have then also voice services, for example, like voice over IP. The difference is, on the real telephone network, you can say your name, and in the voice over IP scenario, you have to say, can you hear me, right? So it's not very resilient, even though it was made for resilience. And this is what we're currently building, the in-network computing network, where computing is really within the network, right? This is where the mobile edge cloud will be placed and so on. So then what we are looking at is who told us what we have to do. There are 3 guys. Do you know all of the 3? Who knows 3 of them? Who knows 2 of them? Who knows 1 of them? Good. On the left, Claude Shannon, right? He gave you the bit. You have the meter and the kilogram. This is the guy who gave you the bit. And he told you there's a limit on the spectrum you can use. So all network operators know that they have to pay so much money because there's a limit you can use. On the right, this is Turing, right? And Turing was the one who invented the computing, so to say, the Turing machine, right? So today we ask about, is this Turing computable, right? And in the middle is Paul Barron, who made the internet architecture, more or less. And by the color of the picture, you can see all 3 are dead. So they gave us the ingredients. We building it according to the rules. There's nothing new since then. And now people talk about 6G. Oh, very funny. By the way, the combination of them is interesting, right? To build a new, you have to talk about internet architecture, Shannon information theory, and computing. That is what we are currently building. Interesting is that Shannon and Turing, they met 1943 over lunch in Boston. And they talked about artificial thinking. And they laid out everything that is AI. I would bet money here that since then, nothing is new. The concept is more or less the same as they discussed it. They don't invent it anymore. They said it has to be done like this. And what changed? We have more computing, we have more data. And if you combine this, computing and data, and find a use case where people they have no clue what they're doing, then you have a use case for AI. So engineers, they don't like it so much because they have a system they understand. Idiots, a lot of data. Medical doctors, that is the right customer you can find. Because there, they don't know what they are doing, because they don't know the human as a system. They have an understanding, but not so much. And then AI helps you a lot. And this we have to learn because our networks in the future will be also behave not as we planned. So for us, it's very important, if you put network on it, it's not CapEx and OpEx, but the network operators want. We would like to establish innovation. And normally when you have an idea as a professor, you need 30 years until it comes to the product. With SDN and NFV, no, it's not. So very easily you can do something. So for example, we had a new idea of doing coding. I showed you something. This is the company we did with MIT in 2012. I think Steinwurf. Here you see a Steam service gaming, right? And you see 0% packet loss, everything is fine. And now we add 2 milliseconds latency and 5% packet loss. And this is more or less how your video conferencing looks when your kids are starting to look at the YouTube or Netflix, right? Suddenly the network is, it's not so much, but the network is not responding nicely. And now when you have this in-network computing, you can easily install coding elements on the way where the stream is. And then you switch something like this. This is just implementing a little bit of software, and then you can see what happens, right? That is what Shannon also told us, and how much coding you need to overcome it. But coming back to this idea, how can we really interact with machines, right? This is the standard way we'll be describing it. On the left, you see an expert. On the right, you see a robot. And you don't have so many experts. If you would like to scale and democratize skills, then you need a way. How can everybody have a robot that can do a certain skill? What we do normally is we take a computer scientist, he will create software of what he understands from the expert, and then he brings it to the robot. This chain costs a lot of money and time, right? And you know it about the cost of the robot, they're going down. The cost of the computer scientist is really humongous. It's 2 to 6 times higher, right? That is the problem. And therefore, with Wandelbots as a startup, but also we as a university, we said, why don't we cut out the middleman? Because computer scientists, they don't like to talk to humans. Why don't we do it like this? We just take some closing. Intelligent closing means actuators and sensors in your closing. You do your skill set, and then we are reading out your body, right? And with reading out the body, now we can use machine learning, very easy. That's a tool that we know since 1943, as I told you. And we can generate automatically the source code for that, right? That's what Wandelbot is doing. If you do it for humans, so this is one glove, for example, and you will see a lot of sensor, but you have already some computing on board, 5G connectivity, and then you can go into the Metaverse or interact with systems. I will not show you all the examples here. For example, we are reporting on what a human is doing while he's working. We're automatically reporting. Or you can interact with cyber-physical systems, right? And instead of doing you can come to our chair and then you can try it out, right? Instead of using the Xbox controller, now it's still easy, but we tried it even with bigger machines, right? To excavate some floors and so on. So the thing is, and this is the masterpiece, when you want to do this not in close proximity, but you would like to do it over the globe, right? Then you have the expert on the left. You have some skill set that you can just record, send it to the other side, but you need the feedback. And the feedback is audio, video, and also haptic, right? And these are the 3 senses. And I told you that their sensibility is 1, 3, and 50 milliseconds. There's a distribution. Some of them are not a little bit different. It changed with the age. And if you look at the y-axis, it said fraction of rats above the chance. The psychology people told me rats and human beings exactly the same. Live with it, right? So, but the sensibility is important. 1, 3, and 50 milliseconds. And in order to get this done, your biggest enemy is speed of light. Therefore, mobile edge cloud is you bring the computing as close as possible, and then you create models. Models of humans and models of the robot, and then they all meet in the Metaverse mobile edge cloud. Say it as you want, but there's a virtual world where we can interact. And so we create virtual locality or proximity. And here are some of the stuff that you would need, right? You need something like network slicing. Why do you need network slicing? Because you cannot send all the sensors in one internet. Then they get all mixed up and they all have the same delay characteristics. What you need is something like TSN or network slicing, where you can really say, here's touch, here's audio, and here's video, right? So for example, we did this here on the left. You can see some distribution. If you do it with TSN, right, what is the latency for one hop? We are talking here about nanoseconds. But if you have more of these hops, you will be adding it up and convolute the distributions. But you can see already for tactile, we can make it better than audio and video. That is never be possible if you have net neutrality. So with that, I think my 20 minutes are over, unfortunately. I would have more material, but then they could not download it, so we cut it down to the 400 megabyte. And I hope that you understand what we are doing here at Dresden. Democratizing skills for everybody, and touch will be one of the things that we need to create this in the Metaverse, to really have an experience that we all want to have and that we don't need to be experts, right? That's important. So I think everything is over, but I will be here and open for some questions. Thank you very much.
Do we have some questions? Hartmut?
You talked about touch. Can you also talk about smell?
Yeah, smell is more complicated, but I tell you something. We are currently building up a bar where you also have robots that can cook, right? And if you have seen robots that cook, like a Thermomix, for example, right? There's nothing else. What are they doing? They're doing always the same or the same. My wife loves the machine. I hate it because I know when I go in the become elder, I have to eat this stuff anyway. But the real stuff that you want to have, like meat and onions, that are a little bit burnt, right? Why don't they do it? They will do you put the onions in 10 seconds, not more, right? You nearly get them raw, and every robot will do the same. But onions or meat, is a product that is depending on the age. How much water is in there, right? You have to understand this. So you cannot do this with cameras and with even audio. So you need the smell. And currently we have some colleagues that are building the digital nose, and they can, for example, tell you 100 different types of coffee of Arabiata. They will tell you exactly what is what. But tell them here's Arabiata and here's a grappa. They don't get it, right? So there is a lot of things that we're currently trying to explain them what information theory can help them, like blind source separation. But soon we will have a digital nose to have at least the smell of the onion for the cooking one. That's what's very important. So it's more about understanding a skill set than bringing back the smell. You remember the times in the 80s or 90s when they said there's a smell TV. I don't want to bring back the smell. But interesting is also how you can translate smell to something else. So it does not need that you recreate the smell. You can just put it on the video screen, right? While you walk in the virtual world, there's something very stinky, you just make it darker, right? Or you make it unpleasant on the video. It shows translation of things. But we believe that the nose is one of the things that we would need to understand skill sets. In the beginning, we did not want to touch it, but since some of the people at Dresden are working on it, we will definitely build it in.
Frank, I don't have a question to you, I have a comment.
Yeah.
We have seen a lot of great presentations over the past 2 days here.
Yeah.
To be very honest, I liked your presentation a lot. It was the best for me. The only disadvantage, it was only 20 minutes.
Yeah.
I would like to ask Dirk, inviting you for next year, June 14 and 15, and give you 40 minutes presentation time.
And the year after that, I get 80.
And please send your presentation in advance.
No, I did it. I think we did it yesterday. I don't know where it is. It came from my secretary. But I think, thank you very much for that. The problem is the topic is, of course, very intense, right? And telling you about touch and smell and all this stuff. The real thing is you have to see it, right? So it's not just that we are talking about it and writing papers about it. We're trying really to build it. And one of the reasons is we are so stupid, we cannot predict it by just formulas. We need to see it, we need to fail, and build on top of it. But what is very interesting is the translation from the digital twin to the metaverse. Do you know what the difference for you is, digital twin and metaverse? So I also thought about, well, isn't it the same? But the digital twin is something the industry people talk about, right? Where you create something in order to build. The professionals talk about it. Like hero briefs were written by experts for experts to read it. But maybe the metaverse, and therefore we should applaud now the Meta guys and Zuckerberg, is to build more of the equipment. It's a consumer product. So they are building it, but we are misusing it for professional purposes. So it's a cheap way for us to get on the hardware. The hardware currently sucks, really. If we talk about latency, we do 5G, and in the lab we know and we can calculate that the latency issue is not on the links anymore. It happens on the sensors and actuators because they are not made for latency. It's a mass product, and computing is a problem. We are too slow. So this is something that we have to deal with in the future. But I know my time's over, right?
Thank you very much.